Hey guys, this is Martin and we're in the cross-site scripting section, and today's lab is DOM XSS in document write sync using the source location search as in one of our previous labs, but this time inside a select element. Okay, so this is a DOM cross-site scripting vulnerability. Again, DOM cross-site scripting happens all locally with client-side JavaScript, so there's no server interaction involved, and we are talking about sources and sync. The source is basically a user controllable location.search, and the sync is the document write, which basically puts the content out on the website. And this makes it a cross-site scripting vulnerability because there is no sanitization or encoding configured. So I'm going to show you how to approach this. So we have our our website here, right? So we go to a product, and then we basically see that we can check the stock here for the number of available units. Now, first things first, which I would do is view the page source. So if there's any interesting script or something, so I can search for script, right? And then I see description, and I got actually 11 matches. So let's scroll down a bit. Here's something interesting. Here's basically a script, a JavaScript, which defines the variable stores. And then you can see that the location search takes in a store ID. Okay, so this is interesting. I take this out first. There's a store ID, and then that store ID is basically used in the document write without any sanitization, right? And what I can do is basically I can take a look at this in Inspector as well, like down here. So I can go in there and do a right click and inspect. So that shows me the DOM, right? The source code, it doesn't have the DOM modified information, like when there is an H script or a script running and it appends things to the DOM. You only see this in the DOM itself, right? But here we basically have our store ID. Here's our script. And effectively what's going to happen is, well, let's start playing with that store ID first and foremost. So let's take this URL out, right? And we basically have a product ID in there. And now what happens if I say and store ID equals 1, right? So for example, and store ID equals 1, because we clearly know that from the search, this is being taken in, right? Like I do this and yeah, no errors, no nothing, but it also didn't show anything. Now, if I go back down here and inspect that element again, I see that there is basically, if you are in one of those options, right? Like here, this was selected. See that was my input. That was the store ID. And now I need to break out of the store ID first because I want to introduce a cross-site scripting payload. But what I have to do first is basically I go back in here and now I say double quotes and then angle bracket end. And then I need to break out of the options tag as well. Options tag, and then I put in my name, Martin, right? And then see how this reflects it. So let me take a look here on Martin. And as you can see, is I was not completely able to break out, and I can also tell you why, because I need to break out of the select, not the options. So I need to break out of the select tag. So basically, let me go back up here and say select and see what happens. And now I look for Martin again. And now you can see I have successfully broken out of this. So I closed the store ID attribute. And then after that, I was able to close out the select tag. Okay, perfect. So now I'm free. And now instead of Martin, I can actually put in like an image, src image source equals X on error equals alert 0. So what that does basically is trying to load an image tag from the source X, which does not exist, which subsequently throws an error and then pops up the alert 0 box. And let's see if that works. And it does. And it has successfully executed my DOM XSS. And this solves the lab. And that's another example of a DOM cross-site scripting. I hope this makes sense, and I see you in the next video. The first Hey guys, this is Martin again. We are in the cross-site scripting section, and today's lab is DOM XSS in an Angular JS expression with angle brackets and double quotes HTML encoded. So that's important to know already. So you already know that angle brackets won't work and double quotes won't work either. And so Angular JS is like a really popular JavaScript library, which is heavily in use. And it contains something called the ng-app attribute. Okay, so this basically allows you to execute JavaScript expressions within double curly braces, right? Like, so this is a special feature which is meant to be not abused, but if it's not sanitized properly, you can actually get cross-site scripting through JS or through JavaScript as well. Okay, so let's fire up the lab and see how we're going to exploit this. Once again, this is a DOM XSS, so that means it's all taking place locally, client-side JavaScript. So there's no server involvement like with the classic XSS or something. This is all happening locally in the DOM. Okay, let's go here first and let's just start searching for Martin, for example, in our blog. And we take a look at our history and we look at the search. And then we send this over to repeater, we send it once more, and then we start taking a look at the code, right? Like, and so basically nothing interesting here, but when the body starts up, right? Like in a minute the body starts up, it starts with the ng-app, and that is like an indication for you that Angular JS is being used here. It's not always for granted because there is obviously security mechanisms to make this secure, but this is something you would test out for. So when you now let's look for app if we see any other references here, and it's only that, right? So it just says body and g-app, but that's basically a keyword. Now what you can do is you can go over to book.hacktricks.xyz, and it has pretty good write-ups around the whole thing. Like it again explains like what Angular JS is, the ng-app attribute, what it's supposed to do, and it's supposed to allow you with running JavaScript in curly braces and things like that. And here you get the syntax, so you can just go in and try one of those syntaxes and see what actually works, or if it actually fires. So if you take this, put it into our search bar, hit enter, then we get our cross-site scripting payload, because we were on constructor, which is like an instruction here in Angular JS, was able to basically give us the pop-up box, as you can see this here. So this is again client-side JavaScript vulnerability. You can use a tool called DOM Invader, which is very, very good at those kind of things as well. And I highly recommend using it in commercial tests or in bug bounty hunting. But for the sake of these labs, I do most of them manually to explain you what's actually going on behind the scenes. I hope this makes sense, and I see you in the next video. Very, very. Hey guys, this is Martin again. We are in the cross-site scripting section, and this lab is reflected DOM XSS. So basically in DOM XSS, you have two components. Number one is something called a source, and the source is usually the user input or untrusted user input, and then you have a sink which passes it to an insecure function. Okay, so in this lab, our goal is to effectively inject JavaScript in order to get a cross-site scripting attack going, and a reflected cross-site scripting attack, so it's not being stored. For that matter, we are going to go over to the lab, and we simply do a normal search function first and foremost, right? So I'm going to search for Martin. I head over to repeater. I take a look at this, and what I immediately see are two things basically. Number one is this is my search, right? So this is my actual search which I've done, and then you can also see that there is a search result.js. Let me send this over as well. So this is the get function, and then we have the search results.js, which is a JavaScript which is being loaded, and then we basically have the actual result. So let me send this to repeater as well. So we got those three here. So this is my first, this is the actual search, right? And then I simply get a 200 response on the actual search, and it says like, nah, nothing was found for Martin. So I can see where do I actually see Martin in there. So you can see this, it's not even showing, or it's not even reflected on that page. And that's for the reason because it uses that search result JS JavaScript. And here you can see there is like a JavaScript function. And what's good practice always is like to look for certain keywords, like for example, eval, right? So it's making an Ajax call effectively, and it's taking the variable search results and it passes that in the eval function, and then it's being displayed as the result object. So this is a dangerous function because it's not sanitized. It's basically taking user input and is passing it unchecked to the eval functionality, which is a dangerous function. Okay, so let's head over to the actual search results, which is this one here. And you can see what's happening is I get a JSON, an application JSON response. And the first thing I'm going to try to do is I want to break out of this, right? Like, so if I put double quotes Martin again, can I break out of this? And I cannot. So you see what happens here, it puts a forward slash and then the double quotes. So it's basically sanitizing this. But I wonder what happens if I would actually say forward slash, like something like this, right? Like, so if I put a forward slash in front of the double quotes, I may be able to bypass that filter and it accepts it. And actually, look, it does. So this is a first good step. And then now instead of saying Martin, I can actually say like alert 0, and then I close the curly bracket. So I break out, or basically I close that JSON function, and then afterwards I put 2 double slashes, which basically means ignore everything afterwards. So let's try this, and you see we were able to successfully actually break out. And what I'm going to do now is simply I'm loading this in the browser, show response in the browser. Not sure if this is going to work because there is actually the JavaScript which has to be invoked. So yeah, this doesn't work on its own. So what I need to do is I actually need to go back to my search bar and then insert this payload manually. And by doing so, I follow the 3 steps. So I have this input, and then it's being passed on to the JavaScript file, and then I get my output results. So let's see how this works, because it needs to be processed by the JavaScript in order to be passed to the eval function, right? So I do this, hit search, and here we go. So my cross-site scripting payload was successfully executed. I hope this makes sense, and I see you in the next video. So hey guys, this is Martin. We are in the cross-site scripting section, and today's lab is stored DOM XSS. So the lab has a stored DOM vulnerability in the block comment functionality, and to solve this lab, we need to call the alert function. Okay, pretty straightforward, but there is a filter which we need to bypass. So let's head over. Let's first of all look at the comment function. So I'm going here in the comment function, and I simply add a basic cross-site scripting payload, like something like this. So image source means like load an image from that source, and then if that source doesn't exist, and if it doesn't exist, then throw an error, basically. So pretty straightforward. I put in test.com. Okay, so I post this comment, and I go back to the block. And what happened is I can see it, right? I can see it here. But if I look at the page source and I look for alert, I should be, or what was it? Image source, img source, img src. So I don't find it. Okay. The reason for that is because it's a DOM XSS. It's not a regular XSS. So this all happens in the DOM. So let's take a look at the inspect element. Let's do this. And we basically see that it has been taking this input, but it's basically displaying it as text, right? So it's in the paragraph tag. So something is preventing this from firing. Now I presume this is the angle brackets, right? So what we can do, what is a good practice is basically head over, go to the target and take a look if there is any JavaScript files or something like this, like, yeah, this looks interesting, and then send this to repeater. So this is effectively a JavaScript file which is being loaded. And let's take a look at this, what it actually does. So we have an Ajax call to start with, and it does a GET request and whatnot. So this is all not interesting. What immediately stands out is this. It says function escape HTML. That sounds like, hey, they're escaping HTML. And what they're doing is they're replacing the, when it's being rendered, they're basically replacing the open angle bracket with this string, and they're replacing the closed angle bracket with that string. Now this is interesting. But what I immediately read, and this is before it's being passed to the eval function, right? What I immediately read out of this is it's only checking for the occurrence of these angle brackets once. So if it's more than once in there, maybe it only checks on the first one. And by the looks of it, it's only replacing one set of these angle brackets. So there is one way to find out. We head back to our blog and we make another post, basically. But this time, let's try something like this. Let's do this, open angle bracket, closed angle bracket, and then our payload. And if my assumption is right, it should basically fire the XSS simply for the fact because based on the JavaScript code, it's only doing this replacement function once as sanitization. So let's post this and let's go back to the blog. And you can see my XSS has now fired because it was in fact just filtering out the first set of angle brackets, but the other ones were passed unchecked. So this is like a logic vulnerability on the developer's part. I hope this makes sense, and I see you in the next video. Right? Hey guys, this is Martin here. We are in the cross-site scripting section, and today's lab is exploiting cross-site scripting to steal cookies. Okay, so so far all the exploits we have fired is just a pop-up window, which is a proof of concept, which is typically fine for bug bounty hunting and things like that, just to show that it's possible to execute JavaScript. But in a penetration test or something like this, or in like a red team engagement, you would want to exploit it to that level that you steal cookies and then perform an account takeover and those kind of things, right? Like to see if there's any lateral movement later on and stuff like that. So basically we have a stored XSS vulnerability, but this time, instead of just firing an alert 0, we are going in and exfiltrate the cookie of that person who is basically browsing to that website, and then the cross-site scripting payload will fire, and then the cookie is being leaked. So that's exactly what we are going to do. So there's numerous payloads for this. And one thing I remember, I can highly recommend is the book.hacktricks.xyz. And there in the cross-site scripting section, you have like a ton of ready to go payloads. And here's one which I'm going to use, which is basically one specifically for Burp Collaborator. So all I need to do here is like, I need to exchange, I need to fill in my Burp Collaborator, which I can get here. So let me open a new one, copy to clipboard, and then I simply paste this in here. And this is my payload effectively. And what this does is it's basically when it's being executed, it is going to exfiltrate the cookie, right, to this domain. It does a post, no course mode, so don't worry about that. But the body document cookie is basically what I'm exfiltrating. This is what I'm interested in. And that's what I'm going to do. And then I just fill in here like my test information, and I will post the comment. And now I'm hoping that an unsuspecting user is browsing to this comment and wants to read that comment post. So I go over to Burp Collaborator and then I say poll now, right? And what I see is I got actually interaction. So I have a DNS query first and foremost, which is not that interesting. Another DNS query, basically, so I get the IP address of the server, but what is interesting is basically the HTTP one, because this was the post which has been sent. And you can see there is like the secret and the session which has been sent over. So this is from the victim effectively, right? And what I can do now is I copy this out, and this is called secret. And I use a cookie editor over here and go into session, and I basically add the secret and put that in. And then I refresh the page and see if this is enough already, which it's not. Okay, that's fair enough. So let's copy the session out as well. So let's copy the session out here and go to the cookie editor. And let's go into the session cookie and modify this, save it, and then reload the page. And now the lab is solved. So basically what I've done now, I've impersonated that user, whoever that was. I don't see this in the lab, but whoever that user was, I was able to successfully exfiltrate the secret and the session cookie, both of them. And then I simply used the tool, like an add-on here in Firefox or in Chrome called Cookie Editor, where I then can manipulate my cookies in the current browser, and that gave me access. Okay, I hope this makes sense, and I see you in the next video. And hey guys, this is Martin, and today's lab in the cross-site scripting section is exploiting cross-site scripting to capture passwords. So this is an interesting lab because typically what you do is, you pop up the alert box or you exfiltrate a cookie like in the previous lab, but there is numerous other ways. In the minute you can execute JavaScript, you basically can do a lot of nasty things, right? And so in this example here, I'm going to show you like how to put like a username and password box, and then unsuspecting users might go there and may enter their credentials, which are then exfiltrated to Burp Collaborator. Okay, so let's go in here. And basically what I'm going to do is I go to my favorite page here. Again, it's called book.hacktricks.xyz, and you have a lot of useful payloads here, like this one, for example. So I can copy the whole thing out basically and then put it into a text editor, and then I can start modifying it. So it's effectively, this is HTML, right? And it's like an input field, username with an ID of username, then the password, and then on change, which means like, hey, when this is being submitted, then what's going to happen is it shall simply send this on to the Burp Collaborator. So I need to obviously fill in my correct Burp Collaborator. Let's open a new one here and copy this over, put it in here, and then it's the post method, no course, and basically the username and the password are being exfiltrated here. So let's put this in. Let's put this in our block comment instead. That's obviously assuming that there's no defenses in place like filtering angle brackets and things like that, right? But so let's put in our details and see what happens next. So I do a post comment, and then I actually go back to the block, and then if I want to see it, I can see something like this. See that? So I have this username and password, and if someone would enter this, I would be able to exfiltrate this. And maybe someone already did, so let me do a poll here. And what I see immediately after the two DNS interactions, there's an HTTP interaction. And let's take a closer look what happened there. And basically what I was able to gather is the administrator. So the administrator filled in their details into that box, and then it was exfiltrated. So I have the username of the administrator, which is administrator, and I also have the password. So let's head over to our account and log in as administrator with that exfiltrated password, and that solves that basically. So this is another example how you can exploit cross-site scripting to do various things. I hope this makes sense, and I'll see you in the next lab. Hey guys, this is Martin, and we are in the cross-site scripting section, and today we are going to take a look at exploiting cross-site scripting in order to perform CSRF. So basically, chaining attacks together if you want. So there is a stored vulnerability cross-site scripting in the block section once again, but this time around we want to exploit that vulnerability in order to launch a CSRF attack and change the email of someone who views the blog comment. So we want to perform an account takeover. So this is basically chaining it together. So let's log in first, right? And take a look on how the functionality actually works. So how do I change my email address? So I have vina@normaluser.net, and then I say 1@1.com, for example. And then I hit update email, and I go over to Burp, and I take a look in the proxy history, like how this actually looks like. So I'm sending a post request to my account change email, right? And what you immediately spot is there's a CSRF token in there. So that means if I load, right, and this is probably going to change at each request. So what I need to check here is if I go to get my account, like my main page, and I look for CSRF over here, and I should find that token, right, somewhere. There should be a token. There it is. This is basically the token. When I loaded the page, this CSRF token was presented to the user. Now, I don't know this, but because the cross-site scripting exploit will be executed under the user itself, it will effectively, it doesn't really matter what that CSRF token is. It does matter, but what you need to consider is you need to simply read this out from the get page, and then you use it in your exploit, and you can dynamically do that. So it sounds all super complicated, but it's actually straightforward. One resource I recommend always is like book at hacktricks.xyz, and you simply go over there and you find payloads for pretty much everything. And all you have to do then is like to modify them so that you can make them work for your specific scenario. So let's take a look at the script, at the skeleton, and see if this is fine. So it's initiating like a new AJAX request, right? And then we need to handle the response. And first of all, we need to open my account, right? Like you remember, we need to open my account, which is basically this page here. So this is the first thing which needs to happen when the cross-site scripting executes the script. And then in the next steps, basically we are defining a token, and we are taking the response from above, from the my account, and we match on a name called CSRF, because we know here that this is the name is CSRF for the token, right? So we basically need to exfiltrate that value. We need to take that value. And then we are basically doing another AJAX request, but this time it's a post request to my account change email. That's what I shown you earlier in Burp. But it's very important that the token which we have exfiltrated from the GET request is being sent along, because otherwise it will fail. Otherwise, there will be a CSRF protection. But because the script runs under that user, which basically gets CSRF'd, I have access to that token. I just need to dynamically build it into it, right? If that makes sense. So let me copy the script and put it into the blog functionality. Let's go here first, right? And we go into a blog post, and then we simply paste it in here, and we say test and test and test again, and then we simply post that comment. And now the lab is solved because it obviously worked. But if we can see it in action, let's see if we can see this in action as well. So I visited this as well right now. Nothing happened, so there was no pop-up box, but in the background, if I go back to my account, the email now should say attacker@attacker.com, which it didn't, right? So this is probably a Portswigger lab kind of thing, because it wasn't intended. I was just trying to see if this worked. And so I load the page, and then JavaScript is being executed. And what I should see is actually that my email is changing to attacker@attacker.com. And it obviously worked, that the lab was solved. It worked for the actual victim, but I couldn't show you this on my own account. But this is probably a limitation in the lab. But that's an example how to exploit cross-site scripting in order to perform CSRF. Okay, I hope this makes sense, and see you in the next lab. A token. Hey guys, this is Martin, and in today's cross-site scripting lab, we are taking a look at the reflected cross-site scripting into HTML context, so a pretty straightforward reflected XSS. However, most tags and attributes are blocked. So you will often find this, that there is waves in place or there's filters in place and things like that. And then it just doesn't work with like the standard attributes, right? However, you can often still get cross-site scripting going, and we will take a look on how to deal with that. So if we come over here, like this is our blog, and if I enter like a standard script tag, right, like something like this, and I hit search, I get immediately a script or the tag is not allowed, right? So this is obviously not good. That means there's some filter in place. So if I head over here and I'm sending this request to the repeater, and then basically this was my script tag. So what I'm going to do is I'm just using like the brackets at the moment without any tag in there, and then I send this over to intruder. Okay, so in intruder now, first of all, my first task is I want to find out what kind of tags are allowed, right? So this is why I put my blank payload position in there. Then I head over to the cross-site scripting cheat sheet from Portswigger, and I copy the tags into a clipboard. Okay, so now I want to see which tag is actually allowed, right? So I go over to payloads, I paste it in here. That's 152, and I run the attack. And in most cases, I should get a 400. So a 400 is basically the response we have just seen, tag not allowed. So the address tag is not allowed, animate tag is not allowed, and so forth, right? So if I now search with 200, I see the body tag is actually allowed, right? So this is kind of interesting because I did not get an error, right? So I take the body tag again and I again send it to intruder, into another intruder session. And then in there, I put a %20, which is a blank, and then equals 1, right? So let's do this. So I will now insert here another payload. And so what I'm saying now is open bracket, body, blank, and then I need to put an event handler in there basically. And then it says 1, like for example, print 1 or alert equals 1 or something like this, right? So once again, I'm going over to the cheat sheet, but this time I'm copying the events, and those are basically the events. And I head over here, I put them in my payloads, paste them, it's 109 events, and then I start the attack once more. Okay, so once this is done, I will search again for 200s. And there is like on before input, on rate change, on resize, and on scroll end. All had a 200, so they are being accepted. So if I take the on resize, for example, so what that effectively means is, so let me show you this. So I'm copying this out. This is effectively, that means body, and let me remove the URL encoding, on resize equals 1. Okay, so this is something which works. So now I know I can use the body tag and I can use the event handler on resize. So what I'm going to do is basically I can create an iframe. I can create an iframe which looks similar to this, and let me copy the whole iframe and show you this in decoder step by step, like what is happening here. I'm putting this into the decoder because then you can read it nicer, because there's URL encoding in there already. So it says iframe source. So markup allowed. So SVG is a graphic format which often is allowed for picture uploads, and developers often don't realize that it can introduce security risks in that respect, that within SVG you can embed JavaScript code, and then this is being executed at the ingestion point, basically, right? So this lab here is similar to one of the ones we have done before, where we need to brute force our tags first, and then we need to brute force our events to see what is actually allowed. So if you come over here, you have your cross-site scripting cheat sheet from Portsquigger, and in the interest of time, I have already done some testings. So basically, this one here, I was making a request, and the request basically was for all different tags, right? So what I got back is that there's 4 tags which were allowed, where I got the response a successful 200, which was title, SVG, image, and animate transform, right? So I'll simply run the burp intruder through this effectively, right? And so I know I can start off with the SVG tag, and then as a second one to actually initiate our payload, I use the animate transform, right? And then I reran the whole thing again, basically. And what I got back is for the events, like you can see here, like I hard coded SVG and animate transform, then I put a blank in between, and then I was basically brute forcing for the event which is being allowed. So the on begin equals 1 was the only one allowed, basically. But that should be enough to actually give me my payload for this exercise. And if this is unclear, go back to one of the previous videos where we have exactly done that, where we brute force the tags first and then the events second. Okay, so let me copy my lab ID here and replace it in our URL. So all this is doing now, it's calling the search functionality, and then you will see that there's a lot of URL encoding in there. So what I'm going to do is I show you this in the decoder so it's easier to read. So I go in here and say, like, decode me this as URL, and then this is how it looks like undecoded, right, or decoded. So basically my URL and then the search, what I'm doing in the search is, first of all, I'm closing any existing tag out with the double quotes and the closing bracket. Then I introduce my SVG tag first and foremost, and then within that, I basically say animate transform on begin equals alert 1. So fire me an alert effectively, right? So I'm taking this URL and I'm going to copy it out and come over here, put it in there, and I got a timeout, which, let's just check something real quick. Yeah, it's the server seems to have timeout. Let's fire it up again real quick. Access the lab. So, I mean, these Portsquigger labs are all free, right? So sometimes things go wrong. Yeah, it's basically, there seems to be a server problem on their end at the moment. But yeah, nonetheless, so this would give you the pop-up effectively. So this is your payload, and the methodology, I think, is clear. If it's unclear, just go back to one of the previous labs and study that again, like how you brute force the different tags and the different events. Hope that makes sense, and I see you in one of the next videos. Hey guys, this is Martin, and we are in the cross-site scripting section, and today's lab is a reflected cross-site scripting attack in a canonical link tag. So basically what's happening is that the lab reflects user input in a canonical link tab, but it escapes angle brackets. So your standard cross-site scripting attack will not be possible. However, there is certain bypasses you can use, and we will take a look at one of them today. So if I go in here and I append a question mark at the end and I say Martin, for example, this is like my first test, right? And then I'm going over to burp and I'm going to check what actually happened here, right? So I'm sending this to repeater. And if I go to repeater, I send it and I see that Martin is being reflected here. So the first thing I can try here is basically I need to keep so that there's an href attribute, but I need to actually close my current one. I need to close my current one out, something like this, right? And then I put Martin again, and then I see how it reflects this. And this looks good. So I'm actually able to introduce the tick value here. So it's not being filtered or sanitized or anything. And instead of Martin, I can use something called access key. So access key is like a functionality which when there is a keyboard combination clicked or a certain value is being clicked, then this is being a code is run or something. Like this is like to initiate a JavaScript initiation or something. Okay, so I say access key equals, and then I want to do this when the button or when the X is being clicked. So this could be anything. I could use this A, B, C, number one, like whatever it is, right? And then let me send this and see how this is being reflected. So this looks good. So access key X, so I introduced this as a new like event handler in here. Access key X, and you see there is a tick at the end, which is automatically being added, which is great. So the next thing I want to do is I say on click. So this is basically my action point. So when this X is clicked, right, then something shall happen. And what do I want to happen is simply an alert function, right? So I put a tick again because the alert has to be within the tick, like an alert one, but I do not need to introduce like another tick because it's already closing it here. You can see that. So if I send this, this should be basically my payload now. So what's happening is, sorry, I forgot completely something, I think. On click equals. So this looks good now. So I have my access key X. When it's being clicked, an alert is fired, right? So how can I test this? Well, I can basically go over, and this doesn't work in all browsers alike, right? Like, so for example, this works only in Chrome in this specific instance. So let's take this URL and let me explain this in more detail in the decoder. So if I put it into the decoder here, you can see like we start off with the access key click X. So I choose the access key X, and then when this X is clicked, the alert one is being fired. Okay, simple as that. So this is tricky to actually execute in the real world. And the reason why it's tricky because it needs some social engineering. And effectively, in order to initiate this, you need to click on the Mac keyboard, you need to click the control option and then X key. And then that initiates the cross-site scripting, as you can see on the screen. But to get a user to do this, it would require some social engineering, like an email to, hey, please follow this for security updates. You need to do something in your browser, or la 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 la. And then it may work, but it requires user interaction. That's why it's not easily to pull off. Okay, I hope this makes sense, and I see you in the next video. Engineer. Hey guys, this is Martin, and today's lab is a reflected cross-site scripting into a JavaScript string with the single quote character and the backslash being escaped. So you cannot use either of them in order to pull off the functionality. So this lab has a query tracking functionality, and the reflection is basically in a JavaScript string. So let's head over to the lab and let's start with some basic payload. So I enter my name in here and then see what the output is. So I head over to the proxy and send this over to repeater and send it on, and then I look for Martin and I want to see where this is being reflected. So I get two matches. One is in the H1 tag, which you would also test in a real engagement, but what I'm interested in today is there's a variable search term, so it's a JavaScript string. So first thing I try to do always is like to break out of it, right? Like, so I see it finishes like with a tick, and then if I say tick Martin, what happens? So let's take a look. And you see that the problem here is that it's basically escaped, right? Like, so it's putting this backslash in front of it, so it's escaping that character. So not good for me because obviously this doesn't work. Then what can I do next? Well, I can try something else. So I see there's a script tag here, right? So there's a script tag. So what happens if I actually say Martin and then I close that script tag and then I put hello? And let's see what happens. Let's go down. And this looks good, right? Like, because what I see here, the script, the closing script tag, there was no sanitization done at all. So basically, I was allowed to introduce this here. So this is pretty good. And then now up here, you see like in the search results, like in the H1 tag, it actually successfully encoded this. So it's not vulnerable in here, but it's vulnerable in the JavaScript string, basically. So I've closed the script tag. The script tag starts here. Now I closed it. And now what happens if I then put in, instead of hello, I put another script tag, an opening one, an alert 0, and I close that script tag out. See what happens. And let's move down here. And you can see this looks quite good, actually, right? Like it's opening a new script tag. It has my JavaScript in there, and then it closes the script tag. So let me run this. Let me show the response in the browser. I actually, you know what? Let me take this payload from here and then simply put it into the search box like this. Hit search, and you see my cross-site scripting was successfully executed. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and in today's lab we are going to take a look at the reflected XSS into a JavaScript string like in the previous lab, but this time with angle brackets and double quotes HTML encoded. So there's protection mechanisms on the angle brackets and on the double quotes. So they are HTML encoded and the single quotes are being escaped. Okay, so multiple defense mechanisms which we have to overcome, but it may still be possible in certain scenarios. So let's head over and put in a normal search term like my name once again. So I'm searching for Martin and I want to see in burp what actually happened, right? So I'm sending this to repeater to play with it, resend it one more time, and I'm looking for Martin, and you see it's being reflected here in the H1 tag, which we're not interested in today, but we are actually interested in the search term, right? Like in the variable, this is the JavaScript string basically. So first test first is I will say Martin and then I say payload, right? So I'm putting a tick in there and see if I can break out of this JavaScript string. And the result is basically no. I cannot do this, and reason I cannot do this is because it's being escaped. As you can see here, it's basically escaping that character, which is no good. Okay, so then my next test would be, hey, what happens if I actually put the backslash in there myself, like the escape sign, and see what happens here. And so basically I can see, hey, this has not been escaped. So maybe now I can now try to introduce like a tick. So maybe I can instruct it to not escape the tick. And this looks good now, right? Like you see that? So basically right now it looks more like, hey, I was able to actually introduce this because it's only escaping it once. But the second one, well, this is server introduced, and that's my input basically. So this is what you see here reflected. And what if I now say alert 1, something like this, and see what the result would be? And this looks good, right? Like this looks like it has taken it, but it will probably mess up the code. So what I'm going to do is I instruct it to ignore everything afterwards with the 2 forward slashes. So in order not to create an error or something like this. So let's check this. And if this is not being escaped, no, this looks good. So basically I have now a working payload, or it should be a working payload. So let me just verify this. Let me copy it and head over and search for this. And if all goes well, I should get my pop-up. And yes, so I was able to bypass all the filters they had in place and get my reflected cross-site scripting vulnerability executed. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and today's lab is a stored cross-site scripting vulnerability where the input is being reflected into the on-click event. However, angle brackets and double quotes are HTML encoded, and single quotes backslash escaped. Okay, so effectively, as you read through this, there is a lot of filtering going on, but let's see if we still find a way to exploit that. So let's head over to the lab, and we see there's a block functionality, and we simply go in here and we start blogging something, and we call this Martin at martin.com, and then HTTP. Let's call this Martin as well for consistency, right? So we send this post, and we go back to the blog post, and we head over to repeater. So first of all, I want to find these two. So this was my post. I send it to repeater, and then the retrieval, I send it to repeater as well. So the first one is the post I actually made, as you see, and the second one is retrieving it. Now I'm more interested in the second one because obviously I want to see where this was all reflected. And I can see various things here. So first of all, I see there's an href, which could be potentially vulnerable to like a JavaScript execution or something, but in this case it's not. We are focused here on the on-click event. So what's happening in the on-click event is when this is being clicked, so when this href is being clicked, there is some magic going on here, and effectively it will be like this tracker will track. So I don't know the backend code for this, but basically it will do a redirect most likely to martin.com. Okay, so now my question is, from a security researcher perspective, can I introduce like a JavaScript kind of payload or something like this? So what would happen if I go back here, and if I make another post and I say, this time I call it test.com, and in the website I actually put something like Martin and then question mark, and then I try to get an alert 0 going here, right? Like something like this, like a basic payload should be working fine, right? Like maybe this works. So let's post it. And let's go back to the blog, and here you see the problem, right? So you see in the left-hand corner that it basically escaped my ticks, right? My single ticks. And in the lab description, it actually said that, right? Like single quotes are being escaped. And so this is no good. But then I'm wondering, hey, what if I use another encoding method for this, right? Like, so for example, let me show you this here in the decoder. This is what I just tried, right? So this is what I just tried and it didn't work. So what if I replace the ticks with HTML encoding, which would then look like this, and apos semicolon, and then to finish it, like the finishing tick would be single quote, would be and apos semicolon as well. So maybe this works, right? Like, so it's all about trial and error. And let's take this payload, and this time around we know that it didn't work with single quotes on its own. So let's try this again. And this time we put in this payload we have just taken here. So let me copy this. Excuse me. And we put this in here. We post a comment. And I have a mistake in there. So let's post it. And it takes a bit, and we go back. And you see it already solved the lab. But basically, if I now click this here, I have my alert function, and you can see clearly that the ticks are visible, and it should fire it when I click it, and it does. Yeah. And so I was able to bypass this filter. If I used single quotes on their own, it it didn't work basically because they were escaped. But if I HTML encoded them, the server was tricked and the correct payload was triggered. So I hope this makes sense, and I see you in the next video or something. Hey guys, this is Martin, and today's lab is a reflected cross-site scripting vulnerability, this time into a template literal in JavaScript, and with angle brackets, single quotes, double quotes, backslash, and backticks are all Unicode escaped. So a lot of filtering taking place here, but there is still ways to overcome this. So first and foremost, like whenever I hear template literal or something like this, or into a JavaScript literal, you basically want to check out this website here, which is called book.hacktricks.xyz. And so there's a nice section in the cross-site scripting vulnerability section where it says basically inside JavaScript code. So that gives you like the options where it's basically being reflected and what kind of payloads you could introduce. But before we look at this, we actually head over to the lab and we simply add our name here again and see where this is being reflected. So this is always my standard testing methodology. So I sent this over to repeater, and then I want to see where Martin is being reflected. And you can see it's in a template literal because you see the backticks here, right? So you see the backticks. So as the lab already told us, so first and foremost, it's in a script tag, right? And it takes the search message and it's basically using the inner text message. So it's basically outputting it on the website. So this is where the danger comes from, because it simply takes unsanitized input, or kind of sanitized input, because it does some filtering, but the developers forgot to introduce certain things or certain filters. So let's head over to this website again, and we see it is reflected, right? So as you can see, it's being reflected here in something like this, like the template literal, so inside the backticks. So what if I use a payload like this and see if I can introduce this successfully? So instead of Martin, I'm now actually replacing Martin with that payload and see where my alert is being reflected. And my alert is being reflected in there, and you can see that even though they have a lot of filtering in place, they did not filter on any of these characters which I introduced. So this should be good now, because this is the search result basically, and then it's being taken and it's being displayed on the website. So the script is effectively executing that code. So let me head back here and try this in the browser. I put this in, and you can see I have my alert box in the lab has been solved. I hope this makes sense, and I see you in the next video.